All right, welcome back to chapter 11, more of 11.2, continuing on to 11.3, which again, the topic is area. We talked about areas of rectangles, which incorporates squares then, last class, or last video, I should say. And then we also talked about areas of parallelograms. How would you find the area of a parallelogram? So both of those involve length times width or base times height, but probably I will refer to it as base times height from here on out. And today we're going to then talk about the area of a triangle and the area of a rhombus. So let's look at this first activity. You should have a note card, scissors, and a pencil, but if you don't have a note card, maybe you just want to sketch the diagram here on the right, which is what I'm going to do, and pretend you have a note card. Okay, so let's suppose we have a note card which we should know, a little bit bigger, is a rectangle, right? So here's a note card, usually in the shape of a rectangle. If I use my note card to create two congruent scaling triangles, that means what I would do is I would just connect one corner to the other corner, creating a diagonal across that note card, and I would have two scaling triangles that are congruent. The height of the note card is different from the base, and of course the hypotenuse, because it's a right angle here in the corner, is going to be different. So those are three different sized side lengths of the triangle, meaning that each triangle is scalene. Now if I took this portion right here and I cut it in half and I remove it and put it down here, what's funny that you guys can't see, I'm laughing at myself, is I'm making hand motions and you actually couldn't see me, so I had to draw the arrow of moving it down. Anyway, side note. So you take that pink triangle, and if I connected it down here and replaced it here, well then I would have this new triangle, or sorry, I wouldn't have a triangle anymore, I would have a what? So I'm going to get rid of this because it would now be gone, right? So I cut that piece away, I replaced it down here, so I'm left with a parallelogram, right? So this is now a parallelogram. Well, what do we know about the area of the parallelogram? We know that it would be the base times that height. Well, this is the triangle, right? The original triangle. Now I have two of them. So the base times the height of the parallelogram is what we originally get. And now if I just want to cut that in half and get only the area of one triangle, it's base times height divided by 2, or 1/2 base times height. Right, so you can write it either of these ways. B, of course, stands for base, as always, and H stands for height, and they must meet at 90 degrees, which is right here in this corner. We could do that with a rectangle. The original figure might have been a rectangle, right? So we would chop that off and get base times height, and then cut the rectangle in half, and that's why each area of a triangle is base times height divided by 2. Alright, so let's apply that really quickly. Calculate the area of this triangle. We would simply do base, which is 15, times height, which is 8, and divide that by 2. I don't have a calculator, so I'm just going to say 2 goes into 8 4 times. 15 times 4 is 60, but don't forget our units and the fact that it is area. Remember, area is two-dimensional. That's why we have our squared here. So it's 60 centimeters squared. Okay, moving on. What if I give you the area and you have to come up with one of the dimensions, either the base or the height? So in this case, I tell you the area is equal to 11.76 centimeters squared. Well, we know the area equals base times height divided by 2. And let's look at this triangle. Well, this is the base, but notice that it's obtuse. So my height is on the outside of the triangle. So this is where the 90 degrees, so I have to extend that base. So my height is whatever this is. Well, I don't know what that is, but I do know my base. So I can say 11.76 equals 5.6 times the height divided by 2. The first thing you should do is get rid of your 2 by multiplying it on both sides. Right, so 11.76 times 2. Let me see, I gotta get my calculator. That's 23.52. And then that equals 5.6h. Well, I divide each side by 5.6. So I find that the height is 4.2. And then again, don't forget about the dimension. We're talking about centimeters, or the units, sorry. So it is a singular dimension, so it is 4.2 centimeters. All right, area of a triangle. I'm assuming you've seen that formula before, you've calculated it before, so it probably wasn't anything new. Maybe you've forgotten why the formula was the way it was, why it was base times height divided by 2. Okay, what about a rhombus? How are we going to calculate the area of a rhombus? Well, here's a grid to help you see why the formula is the way it is. So create a rhombus on the grid below. Well, remember, a rhombus has 4 sides that are equal in length, and what else do we know? Opposite sides are parallel. So how would we draw a rhombus? Well, if you're trying to draw it like this, that's 3 units across. Well, how do I know what 3 units up is? If you're trying to do something like 1, 2, 3, well, that's not 3 units, right? Because these are diagonal, so that's longer than that. So sure, we could make something like that, but that's boring. But I guess that works as a rhombus, but let's try to do it diagonally instead. Now diagonally, it's really not going to get any much more interesting, but if I went across here, okay, so actually let's make it smaller. I made it 3 diagonal units here. So what's that? That's a good question for you mathematically. How long is that? And I did 3 this direction. 1, 2, 3, cutting through. So that means these are the same length because I'm cutting through those diagonals. And then I go 3 this way, and then I go 3 back this way. So really my rhombus is like a diamond. So all of these are the same length and the opposite sides are parallel to each other. Now, it says step 2, draw the diagonals of the rhombus. Well, here's a diagonal of the rhombus, and here's a diagonal of the rhombus. And what do you notice about those diagonals? Diagonals of a rhombus intersect how? They intersect at 90 degrees. Hopefully you could see that, and hopefully you remember that from last semester. So they intersect at 90 degrees. Well, look at that. Look at what you have here. You have a triangle, 2 triangles in fact, right? And the base of the triangle is 1 diagonal, and the height of the triangle is half of the other diameter. So what would we get there? Ooh, that's interesting. So for the area of this yellow triangle, right, I would get diagonal, so we'll call this one diagonal 1, and this one right here is half of diagonal 2 then. So that would be diagonal 1 times half diagonal 2 divided by 2, because it's the area of the triangle, and a triangle is base times height divided by 2. This is my base, this is my height, this is my divided by 2. Well, what is 1/2 divided by 2? That's 1/4. So it's 1/4 diagonal 1 times diagonal 2. Okay, that's just for the yellow triangle, right? So if I do the other triangle, don't forget there's 2 of them. And what do we know about these triangles? We know that they are identical in size because I split it in half. So the second triangle is the same. The area of the green triangle should also be then diagonal 1 times half diagonal 2 divided by 2. So that's 1/4 diagonal 1 times diagonal 2. Well, we have to do what with those 2 triangles to get the area of the rhombus? We have to add them up. So 1/4 diagonal 1 times diagonal 2 plus 1/4 diagonal 1 plus diagonal 2 equals area of the rhombus, which is 1/2 the diagonals multiplied together. So that is how this formula came about. How do you find the area of the rhombus? You multiply their two diagonals to each other, and then you divide by 2. Again, if you're not understanding this, either go back and listen again, or please ask me in class. So I'll see you tomorrow or the next day, so ask me in class and I'll be happy to explain it to you. Okay, can you apply it? So calculate the area of this rhombus for number 3, calculate the area for rhombus number 4. Go ahead and push pause and try it, and then come back and see how you did. Okay, so number 3, it's a pretty basic question. You can see the diagonal. This is 2 and 2, which means one diagonal has a total length of 4 units. The second diagonal is 5 plus 5, which has a total length of 10 units. Therefore, we multiply 10 times 4, divide it by 2. You should get 20 units squared. Pretty straightforward. Number 4 is a little bit more complicated. I believe this is just saying that this portion right here is 16 units, which means the opposite portion from the center out to letter G is also 16 units. Remember, your diagonals intersect at 90-degree angles. So if you notice out here, GE is equal to 20 units, and that's the hypotenuse of a right triangle right here. So I need to use the Pythagorean theorem to solve. So half of the length of this second diagonal, or x, I labeled it x. So x squared plus 16 squared equals 20 squared. I did that work over here, right? So I squared 20, squared 16, subtracted over here. 400 minus 256 is 154. Square root of that is 12. So now I know that this little piece is equal to 12 units. Well, if that piece is 12 units, it's also 12 units over here because diagonals bisect each other. Not only do they intersect at 90 degrees, they also bisect each other. So one diagonal is 24, another diagonal is 32. We multiply those two together, divide by 2, and I get 384 centimeters squared. Our final area we're going to find today is the area of a trapezoid. So once again, if you can do this activity, please do. And then see what you can figure out from your figure. So go ahead and pause or try to sketch it. Try to figure out what's happening here. So pause and figure it out. Okay, so you start with your note card. And I would say you're going to measure right the same distance here. So you can see this is one trapezoid. I have this length, this length. If I make this length the same as this one, so if I call this one base 1 and this one base 2, that means this is base 1 and this is base 2, and I would call this my height because it's intersecting at 90 degrees. Well, if you take this piece right here and slide it over, you can put it right here on the edge, right? Match this up right here with this, so everything slides over. So now this base 2 is right here. And this base 1 is right here. And so what do we end up getting? We end up getting base 1 plus base 2, which is the length of the whole bottom half, times our height. Here's our height right here. It still exists. And then divided by 2. So where is that coming into play? Well, we don't want 2 trapezoids. We only want one of them, so we have to divide that in half. Right? So think about that. Right, moving on to our examples, calculate the area of this trapezoid. Well, we just applied that formula, so I'm going to get 1/2, the area of the trapezoid is 1/2 the height times base 1 plus base 2. We would go ahead and calculate that. So 28 plus 16 times 4.5 times 1/2, and I get 64 centimeters squared. And for this last one, go ahead and try this, pause maybe and try it on your own, and then come back quickly to check it. I'm out of time to explain it. There's only 10 seconds, so have a look, pause if you need to look at it, or ask me in class. 3, 2, 1, bye.